Assalamu alaikum guys, welcome to data analysis projects tutorial. So before diving into the VS Code and performing analysis on them, a question may arise, what exactly the time series? Okay, so time series is basically a series of data points indexed in time order. So for this project, we are going to consider data of S&P 500. So what is exactly S&P 500? So it's just a stock market index that measures the stock performance of somewhere around 500 giant companies of the USA. Now, question will arise: what type of analysis you can done on this stock data? Let's say uh, 8%, and there you have this least value, and there you have this least value for that type of analysis you can done on your data. Let's say uh, so there's another analysis that you can done on each of the stock company data. So for what you are waiting, just go ahead to the project and keep enjoying. Actually today we are going to analyze this problem statement, okay, and we will try to find a solution uh, of this problem by analyzing them and creating meaningful visualization out of them. Okay, so first let's create a file. Let's say stock price dot ipynb. Okay, now import the necessary modules that will be needed in this particular tutorial. So import first pandas as pd, numpy as nt, import matplotlib. Actually these are the basic modules that need almost every kind of analysis. Okay, like pandas is very important to work with data frame. NumPy is important to deal with like our statistical analysis. Okay, and Matplotlib is very important for visualization purpose. So import matplotlib.pyplot as plt. Okay, for now this three module, and I'll select here uh, environment, and first let's have a look at our dataset. So there are various or several stocks dataset. Okay, so like here is Apple, Google, Microsoft, Amazon. Okay, so among them we are only going to select Apple, Google, and Microsoft, Amazon stocks. Okay, for analyzing purpose we need to first define path and then the dataset name. Okay, so let's first create a path. We are going to name the path like individual stocks 5 year. Okay, individual stocks 5 year. Okay, and then I'm going to create a list of like company list, name it company list. Okay, and then going to name the dataset that we are going to like import in. Okay, I'll select Apple, like there is AAPL dataset. Okay, this is Apple stock, Apple data. and apple data.csv. Okay, then ms Microsoft msft data.csv, and then well, underscore data.csv, and then amgn underscore data.csv. So we have created a list of the dataset we are going to deal with. Okay, so or empty I'm going to create an empty data frame, all result pd dot data frame, that will create an empty data frame. Okay, and then I'm going to run a loop to iterate all the company. Okay, so I'm going to create for loop for company for company in uh, company list. Okay, and then I'm going to call pd.readcsv pd.readcsv, and uh, first I'll give a path as a parameter, and then I'll add a backslash forward slash, and then I'll add the file name. Okay, or the company. Okay, okay, then and I'm going to store this as current. Okay, current data frame, and after that I'm going to concate. Okay, concate current data frame with the all result data frame, all result pd dot concate all result. I'm going to concate all result data frame with current data frame. Okay, so every time current df will be added with our main data frame or the mother data frame all result. Okay, so okay, now uh, okay, now execute this line of code, and we got an error here. Here I messed up one thing. Here I need to pass the my current data frame and my uh, reference data frame. Okay, by into a square bracket. Okay, so now the moment we'll execute this line of code, it will compile successfully. Okay, okay, so now let's look at our concatenated data frame. So dot head, let's see top of the first five, and this is what we are getting. Okay, we are getting date, we are getting open price, we are getting high value like high price and low and uh, closing price. Okay, and the volume uh, of that company and the name of the company. Okay, the name of the stocks. Okay, let's uh, look at the shape of our newly created data frame. So we have 7 features or 7 columns and 5036 rows. Okay, now we are going to analyze closing price of all the stocks. Okay, okay, to analyze the closing price of all the stocks, so first we need to uh, extract the unique company. Okay, we need to create a list of the company. Okay, that of all the unique company. So for this, let's okay. So this let's let's say all result dot all result company or all result name. Okay, dot unique. Okay, if we execute this line, so okay, we are getting this type of array. Now let's store this value into to a list. Okay, called uh, text list. Okay, okay. So now we are going to create our first visualization by uh, analyzing closing price of all the stocks. Okay, for this we are going to uh, use subplots. Okay, we are going to create several visualization or plots for all the stocks if individually. Okay, so for this we'll use subplot. First create a loop to iterate all of the stocks. So for company in, okay, tech list. uh, okay, first of all we will use enumerate here. The reason I am going to discuss after the code. Okay, so enumerate uh, list, and I'm going to start indexing from 1. Okay, and here I'm going to access the index by using I. Okay, okay, then uh, I'm going to use plt dot subplot. I'm going to use 2 by 2 plot. Okay, and I'm giving argument parameter I, because okay, now I'm going to discuss, or I'm going to tell you why we use enumerate here, because we are going to use, since we are already told that, okay, that we are going to use the uh, visualization, or we are going to create visualization for each stocks. Okay, so here enumerate count, or this I returns the total number of company that we are going to uh, that we have in technical list. Okay, so here we have a 4 company or stocks. Okay, so this so we have will this subplot will create 4 individual plot for each stocks. Okay, that so the analysis will be several for several stocks. So we'll understand perfectly after executing this code. Okay, so I'm going to check if the country if the stocks or company, okay, is in the is in our data frame. Okay, so first we are going to uh, apply a condition like all result in all result data frame, the company is equal to the company uh, that, okay, we have got into from this unique function. Okay, and then I'm going to store it, or I'm going to pass it uh, again in all result data frame. Okay, to get the company name that have matched. Okay, and then I'm going to store it in data frame df. Okay, now this data frame uh, contain the company. Okay, uh, only the company that is present in this list, technical tech list. Okay, so Now I'm going to use plt.plot and pass two parameter here. One is our date, okay, and another one is uh, stock, okay, and then I'm going to give a title, okay, and which will be the company or stock name. And now the moment we'll run this code, will we messed up. Uh, we need to analyze. Okay, we need to analyze the closing price of all the stock. So uh, uh, against date, we need to give here close. Okay, close parameter or close feature. So now the moment we run this code, we'll end up getting uh, four subplots. Okay, so let's see, because we have here in tech list we have four companies, okay, four unique companies. And okay, by in this line of code, this iterator in for loop, okay, I comma I, that means enumerate will generate automatically or by default the index of the uh, according to the length of this technical tech list, okay. So in tech list there are four uh, values, okay, so it will generate four index, that the index will start from 1 because we pass a parameter 1, okay, here. And so the subplot also will create 4 times, okay, and then every time we will analyze different stocks, okay, closing price according to the date, okay. So okay, so if we have a look at this visualization, the x-axis is a little bit messy. So to solve this issue, let's say uh, we'll first let's try to change the figure size, okay. So pld.figure, uh, pld.figure, and give a fixed size of, let's say, 15 by 5. And okay, here we have still uh, got the same problem, okay. So okay, now check if check the data types of uh, our data frame of all the features, okay. So dot data types, uh, to check all the data types here, we have an issue because the date feature is the data type of date feature is object or string, okay, but we need to uh, set it to date time data type to get good looking visualization, okay, or x-axis perfectly here. So first let's change the data type of this date features. Let's say all result date, okay, equal pd dot, let's use a two date time function, okay, of pandas, change the date time, uh, okay. So and we'll give an parameter here pd dot to date time, I will give all result and date, okay. So this will change the data type of all result date, okay. So to see, let's run this code again now, and here we can see that data type of date has been changed, okay. So now if we run this or execute this line of code, this block of code again, we'll end up getting this uh, visualization, but still there are the visualization is little bit messy, right? So if we increase the figure size, okay, so let's see what happened. Okay, now it is looking good, okay, right? Because there are no overlap uh, between the individual visualization, right? So their first visualization, um, the closing price or uh, across or according to date. Okay, it's showing for Apple stock. It is uh, it is saying that from 2013 to 2015 the closing price stock closing price is increasing. Okay, but suddenly in 2015 to 2017 or before 17, okay, the closing price has a sudden down. Okay, but after that time the closing price is increasing exponentially, right? Okay, but in Microsoft, if you look at Microsoft, you can see it uh, almost have an exponential increasing, right, increment from 2013 to 2018. Similarly Google, okay, and Amazon, we can analyze the closing price, uh, the closing price of all the stocks, okay, individually. So for this part to uh, achieve this visualization, we actually used subplot here. Okay, and to for this parameter of I, we used enumerate, which will which usually generate uh, the index. Okay, we have already discussed about it. Okay, and now our next problem statement is saying to analyze the total volume of stock being traded each day. Okay, so uh, we are going to need this block of code. So let's copy this and paste it. We need to for this as our second problem statement, we just need to change in this feature. Okay, we need to give volume instead of close. So to analyze this, and now run this code again, and this is our desired uh, output. Okay, so here we are getting the visualization, okay, of different individual stocks. Okay, that will tell us the volume of total volume of stock traded each day. So we can analyze the volume uh, okay, that uh, traded each day. Okay, now I'm going to show you the this exact analysis or this exact visualization. Okay, the using Plotly, okay, which is a visualization tool. Okay, of that is Python. Now I'm going to show you this exact visualization or this exact analysis that will be in Plotly, which is also a Python module, which is especially uh, created for visualization purpose. Okay, so now for this purpose, import Plotly dot express spx. Okay, then import this view, and then uh, use a for loop. Let's say for company in backlist. Okay, and we don't need enumerate. We don't need to use enumerate here. Okay, okay, I'm going to apply condition again, uh, where I'm going to ask if uh, the name or the company is unique. Okay, and I'll pass this value again to the data frame. Okay, and then store it in df. Okay, and now going to use px dot f function of Plotly, which is px dot line, where I'm going to pass data frame. Okay, df, and in x-axis I'm going to use date, and in y-axis I'm going to use let's say volume. Okay, and I'm going to give a title, let's say company. Okay, going to show fig dot show. Okay, show the plot or visualization. Now the moment we'll run this code, we'll end up getting some handy visualization, or that is really helpful to visualize more perfectly. Okay, so if we compare this line of code to this line of code, we see we get the same output. Okay, we analyze the same problem statement but in two different ways, which we use Plotly, and another one we use okay only normal uh, visualization tools like Matplotlib. Okay, and where if we compare them, we see uh, we have to use enumerate and subplot function to see individually of the okay to see the analysis of individual stocks. Okay, but uh, in Plotly we don't need to use enumerate uh, or subplot function. Okay, since the Plotly or px okay handle all this issue. And one more important thing, we cannot modify or customize anything in this uh, Matplotlib kind visualization. Okay, but in uh, Plotly we can customize or modify our visualization. How? If we want to, let's say we want to see more specifically, okay, specifically our closing or price or volume, okay, of our stock. So we need to just select, let's say we want to see this portion. Okay, so we need to select this, and this will end up showing us the uh, in-depth analysis. Okay, and if we select further, it will just zoom in and uh, take us in depth, and we'll get a perfect visual. Okay, and here we can use this uh, various kind of features, like to reset axis we can press this button or click this, and then you can zoom in and zoom out here. So this totally give us a really beautiful features. Okay, to so sometimes this plotly module, okay, is really works like uh, it's really helpful for various visualization. Okay, like this. uh, so so okay, so jump into our next problem statement. We need to analyze the daily price change in stock. Okay, okay, so daily to calculate the daily price in stock. Okay, we need to uh, remember one formula, like okay, we need to uh, but the formula for daily price change, which will be the closing subtraction of closing price, okay, and opening price. Okay, this will be resulted in daily price change for a stock market. Okay, uh, and if you want to get the percent, okay, we need to just divide daily price change in daily price change by closing price. Okay, and we need to multiply the result. Okay, with 100 to get the percentage of daily price change. Okay? So we need to remember this formula to uh, so we need to remember this formula for the sake of uh, analyzing this, okay, problem statement, or to solve this problem statement. Okay, for this part of analysis, I'm going to use a specific data set. Okay, specific stock. Okay, so I'm going to use pd.read csv one, to get the saying. I'm going to extract or import Apple data. Okay, Apple stock. So here a apl data dot csv. Okay, and I'm going to store the data frame to df. Okay, and we will execute this code. Then let's see the head this data frame. Okay, here now our task is to calculate the uh, daily price change. Okay, or daily price returns. To calculate this, let's make a new feature called daily price return. uh, you know the formula, right? So let's use this formula into code. Df closing price, close minus df open. Okay, so now let's say, let's see the head, the data frame, right? Okay, okay, okay. So our next problem statement is to showing to get the daily stock returns. Okay, so these 3 and 4 statement is same. Okay, is almost same or exactly the same thing. Okay, so now we just need to uh, calculate one more thing, which is the percentage of returns. Okay, uh, percentage of daily price returns. uh, we are going to apply the second formula, right? This one. Okay, we're going to use df close minus df pen. Okay, and we are going to divide the result by df close. Okay, and multiply this, multiply the value with 100. Okay, so let's execute this line. Now let's see the head of our data frame. Okay, so from now we are going to work with this feature. Okay, the percentage daily price returns. Okay, okay, now get this now let's get a visualization for this daily price returns. Okay, so I will use again a plotly for this visualization purpose. Since we have already imported the plotly module, so we don't need to import it again, and now we'll use directly the function figure big equal px dot find. We will pass pf. Okay, then in x-axis we're going to use date, and y-axis we're going to use our percent of daily uh, daily price returns, and I'm going to give not I'm not going to use any title. Okay. Okay. So then I'm speak dot show to show the visualization. Okay. So okay. So let's say we want to see this peak value. Okay. In more depth. Okay. So we just simply select this part, and now we can see it in more depth. Okay. And analyze it in more more good way. And analyze it in more specifically, right? uh, okay. So if we again select this portion, we can go into more depth. Okay. So here we almost go so okay, so here we almost come into this. So okay, so here we can see almost the 1 day difference, right? uh, 22 August, 23 August, and 24, 25, 26, almost in the day scale, right? But if we reset this visual, we see uh, first we see the value month wise, right? Or year wise, like 2, 13, 14, and 15, right? But after zoom in or selecting particular area, we can have the access, or we are able to uh, but after selecting a particular area, we are able to see it uh, by day or month. Okay. So this again, this plotly visualization is really very helpful and handy. Okay. So we need to use this in perfect cases. Okay, for now I'll reset this option, and since we are analyzing with the Apple stock data set, right? So we can say uh, Apple got its peak, okay, peak price or peak uh, daily price returns in 2015. Okay. After 2015 to 2016, right? So and can access the specific month and also the day, right? So by this is how we can analyze the daily price returns by using plotly visualizations. Even in more depth, it is giving us the exact time, right? Not only the month, day, or date. It is giving us the exact time uh, of daily price returns, of its downfall and its uh, increment, right? Okay. So let's go into our next uh, problem statement. Or okay. So our next problem statement is saying to analyze the monthly mean of closed column. Monthly mean of closed columns. Okay. Uh, so we need to find the mean of close. Okay. And show it by visualization month wise. Okay. So one more thing here, uh, after selecting this particular area in shortly, we see the value, okay, in more depth, right? Or we can visualize it in more depth, like this month wise. So if we want to see this exact same thing, okay, exact thing, or and visualizing it using Matplotlib or PLT, okay, we can do this. Here first I'm going to create a copy of our data frame, okay, and then going to see the data types, copied or newly created a data frame. Here date column is showing as object, but we need to change the date data type, okay, to date time data type, right? So we can simply use our previous technique to change the data type of date. So use df2 date, okay, equal pd dot use to date time function, okay, and here df2 and date. So this line of code will change the data type of date, okay, into date type. So and then I'm going to use this date as index, okay. So now so for this I'm going to set index df2 dot set index. I'm going to use date as index, and here I'm going to so make the changes in the main data frame. So in place true, and okay, now let's see the head of our data frame, okay. So here we can see that, see this date is showing as index of this data frame, right? Okay, so we can draw one important thing here, uh, since in our previous plotly visualization, we saw that we can easily customize or modify our visualization by selecting a particular area and going into depth of this visualization. By we can access year wise, month wise, and day wise, and even exact time wise, right? So mm, uh, we can see this, or we can do this same thing by uh, our only plot function. Here we will see an example, like if we want to, let's say we want to access mm, a the data or the price daily price returns from 2015 or July 2015 to January 2016, okay. We want to see the stock price returns or daily price returns of this duration, right, of this duration. So we can simply use df to the, let's say 2015 0 July, and the date, any date, let's say 01 and 2. Simply, actually we use slicing here. We use slicing because we slice the date of 2015 to 2016. We only need this duration of date, right? So we use slicing to do this task. um, Here we use 2016 and then 0101, okay, or 31, and we use against this date we use a feature called percent daily return, daily price returns, okay. And I'm going to plot this, and now we can see that it is successfully implemented. So here you can see we can access the month wise uh, price returns, right? So this is how we can modify or customize our visualization by using this slicer or slicing the uh, data. Okay, for this we need to keep in mind one thing, that we need to first convert our date column into index, right? Because this will end up getting an error if you use date as a column. Okay, so first you need to change it or set index date, and then we can use this or access this uh, line of code, and then we'll get our this desired output, right? So this is how we can use specific area or to analyze, okay, or to visualize without using plotly. Okay. Okay, so uh, moving to our current problem statement, we need to analyze monthly mean of closed column, right? So for this we'll use resample function. Okay, so we simply use df to close, uh, because we need to analyze, okay, closing values of stocks. So close dot, I'll use a resample function where I'll give a parameter m, and I'll use a aggregate function of mean. Okay, and then uh, okay, so how this line of code actually implement this or solve this problem statement. Okay, so monthly mean of closed column. So this line of code actually means we here get the access of closing values of stocks, right? And resample m, that means we can access the month-wise values. So this m for means month. Okay, and we are getting the aggregate function mean. Okay, so we are getting the value of mean. So here monthly, this portion will work for monthly values, and this portion will get us the mean value, and this one is closing price value, right? So this is how we implement this line of this problem statement. Okay, so the moment we'll execute this line of code, we'll end up getting a series like this. So here date is uh, index, and the value of this is okay, like here these values are the mean of the closing price. Okay, so now if we want to plot these values, okay, so we simply use dot plot function, and this will automatically plot as the perfect figure. Okay, so this figure represents the monthly closing price, okay, by mean. So monthly mean of close column. Okay, so this visualization is simply represent the monthly mean of closing price. So we can similarly get the value of for yearly, okay, for year wise, by set this parameter m to y. Now we can get the here this is showing us the yearly mean of closing price. Okay, so resample function is very important because it uh, can because it give us the access to uh, because so resample function is very important because it give us the flexibility to get the access of monthly wise, yearly wise, and daily wise, right? So this is how we implemented our the fifth problem statement, analyze monthly mean of close column or yearly mean of close column or closing price. Okay. Okay. So our next problem statement is saying resampling close column year wise. So we have already done this in this line of code. Okay. So and seventh problem statement is saying uh, to check if the stock price of these tech companies like Amazon, Apple, Google, Microsoft are correlated. Okay, so in this problem, we need to correlate, or we need to find or determine the correlation of variables or these uh, four giant tech companies. Okay, among with their according to their stock prices. Okay, to get the stock price of tech giant companies like Google, Microsoft, Amazon. Okay, we can do one thing, which is we can uh, concate or merge closing prices of all these tech companies or stocks, right? So we can do this task by uh, first we can create a empty data frame, pd dot data frame. Okay, so can and then after this, okay, and then we will iterate, will after that we'll run a for loop. Okay, to iterate all of the tech companies, uh, like for company. Okay, in tech list, and here we'll do something we have done in previous code, right? So we'll all result will check for a condition, all result uh, name equal to company. Okay. Okay, so and then we're going to close use this uh, okay, so let's see what this line of code gives us after executing this. uh, okay, now if we uh, see the head of this data frame, we simply uh, get the closing prices, okay, of different tech giant companies like Apple, Microsoft, Google, and Amazon, right? So now we are going to perform multivariate analysis, which is nothing but the statistical study of data where multiple measurements are made on each experimental unit. Okay, we can uh, apply multivariation analysis uh, using SNS or Seaborn module dot SNS, which is SNS dot pair plot. Okay, where data will be where data will be where data will be uh, or close okay, close data frame. Okay, sorry, so need to import first Seaborn library, Seaborn as SNS. Okay, that uh, sorry, use pair plot. Okay, so this is the our multivariate analysis. Here uh, we get the measurements on each experimental unit, like we can compare Apple stocks feature with Microsoft, Google, and Amazon individually and separately. Okay, next we can seek for correlation between different stocks by using SNS.heatmap. Okay, here give data parameter as close, okay, dot correlation CORR that will return us the correlation between different uh, features or okay different column, and then I'm going to execute this line of code. Okay, so here we don't get any value, so for value I'll use anode true. I'll set anode true, and this will show us the value. Okay, here uh, this is uh, here this is apparent that uh, the correlation between Microsoft and Google is 0.97, which is nearly uh, equal to 1, or we can say that the uh, correlation between Microsoft and Google is very good. Okay, there and then Amazon and Apple, the correlation between Amazon and Apple is also uh, fine. Okay, next look for our public statement. Okay, so let's go to our next public statement. uh, so it is saying reading data of tech companies that we have already done. Okay, and then saying correlation plot for stock prices. Okay, uh, we have also done this, right? This visualization is represent this problem statement. Okay, now we are going to perform one last thing, which is we are going to perform this exactly same variate multivariate analysis and this correlation analysis. Okay, heat map using heat map from Silver library. For um not this time we have done this perform this analysis, okay, for closing price or stock prices, uh, but now in this case we are going to perform the same analysis for daily return exchange, right? Daily price return. Okay, so uh, we need to copy this line of code, this, okay, and then we need to just change here uh, minus, we need to apply the formula, okay, to get the value of daily return exchange or percentage of daily price return. So going to use the formula df close minus df opening or open, okay, and then we divide the value of the result with by df close, okay, and then going to multiply it 100. Okay, so now let's check our data frame head dot head. Okay, and okay, so this will show us the percentage return price, okay, daily return price. Okay, so now we're going to do this same visualization or same analysis in this uh, feature. Okay, so use sns dot pair plot to perform multivariate analysis where data be data will be a close data frame. Okay, and Okay, so here we get normal distribution case of apple. Okay, uh, and for other stocks, the their relation or their comparison is not that much good, because they are like scatter plot. They have uh, constitute like scatter plot, right? So this is not a good sign, okay, of their relation. So now if we apply heat map and use data close dot correlation, and then we'll let's set anode equal true, and the moment we'll execute this code, we'll end up getting this heat map where it shows really poor correlation uh, between different stocks. So there are uh, not that much good correlation between different or several stocks, right? Here we can apply a statistical method called descript. Okay, we can apply a describe method in our close data frame dot by using dot describe. Okay, and this will give us a overview of uh, different feature of this data frame, right? Like count, mean, standard deviation, mean and minimum, maximum. Okay, okay, and we can transpose this uh, by using dot p. Okay, this will transpose this data frame. Okay, so this is how we can perform time series analysis uh, by performing a case study on stock market analysis. Okay, so if we want to recap, so uh, to recap what we have done till now in this particular tutorial, we have solved this uh, 9 problem statement. Okay, we have analyzed this 9 statement or 9 objectives and using necessary visualizations. Okay, so thank you guys for watching my video till now. So that's all for today. I'll see you in next video. uh, Till then, goodbye. Assalamu alaikum.